Good day. Welcome to Lesson 5, and today's topic is about fuels. Our main objectives are, by the end of this lesson, you must be able to understand the definition of fuel and calorific value, classify the different types of fuel and its goods characteristics, to determine the approximate and ultimate analysis of a coal, and identify the classification of fuel according to its state of occurrence and its application. So we will start our discussion in defining what is fuel. Then we are going to have the solid fuels, liquid fuels, and finally gaseous fuels. In this present age of rapid industrial development, the power requirement is increasing day by day. Heat energy is the main source of power. Burning the carbon, an exothermic reaction which produces heat energy. Hence, the carbon compounds have been used as the main source of heat energy. Fuel in any compound that has stored energy. This energy is captured in chemical bonds through processes such as photosynthesis and respiration. Energy is released during oxidation. The most common form of oxidation is the direct reaction of fuel with oxygen through combustion. Wood, gasoline, coal, and any number of other fuels have energy-rich chemical bonds created using the energy from the sun, which is released when the fuel is born. Chemical fuels, or the fossil fuels, are useful reserve of fuels and are therefore used extensively to satisfy the demands of an energy-dependent civilization. So by definition, fuel is a combustible substance containing carbon, which on combustion process or produce a large amount of heat, which can be used for various domestic and industrial purposes. The main sources of fuels are coals and petroleum oils available in Earth's crust, the amount of which are decreasing day by day. These are stored fuels called fossil fuels. Fossil fuels are non-renewable energy resources which are stored up millions of years ago by photosynthesis. So any chemical process accompanied by the evolution of light and heat is called combustion. It is simply the reaction of substances with oxygen and converts chemical energy into heat and light. The process of combustion involves oxidation of carbon, hydrogen, and etc. of the fuels to carbon dioxide, water, and the difference in the energy reactants and the products are liberated as large amount of heat energy, which is utilized. So simply, combustion is the reaction between the fuels and oxygen that produce a large amount of heat and its other products such as water or carbon dioxide. We may classify fuels according or based on its occurrence and to its physical state of aggregation. Under occurrence, it can be natural or primary fuel, which are found in nature as such as it is used. For examples are wood, coal, petroleum, natural gas, and others. While artificial or secondary fuels are those which are derived from primary fuel. Example are charcoal, coke, kerosene, diesel, petrol, or producer gas. While based on its physical state of aggregation, fuels are classified accordingly by pure solid, liquid, or gaseous fuel. Under solid, some example of solid fuel that are natural or primary fuel are wood, peat, lignite, dung, bituminous coal, and anthracite coal. While charcoal, coke, petroleum, coke, and coal briquette are examples of solid, artificial, or secondary fuel. While crude oil or petroleum is an example of a primary liquid fuel. And when this petroleum is being processed or refined, it produces petrol, kerosene, diesel, alcohol, and other fraction of this petroleum, which are examples now of an artificial or secondary liquid fuel. For gaseous fuel, we have natural gas for the primary, while artificial, some of the examples are coal gas, oil gas, biogas, water gas, producer gas, and LPG. So what are the characteristics of a good fuel? So we have here some lists of a good fuel. So a fuel should have a high calorific value. Later on, we will discuss what is the meaning or the definition of calorific value and how can we determine this quantity. Second, it should ignite easily. So ignition temperature is the minimum temperature at which the fuel is an air-liquid mixture ignites spontaneously and continues to burn without any external heating. So ignition temperature should not be either very high or very low. It should be moderate. Low ignition temperature is dangerous for storage and transport of fuel, while having high ignition temperature causes difficulty in igniting the fuel. But the fuel is safe during storage, handling, and transport. Hence, the ideal fuel should have a moderate ignition temperature. Fuel should have low content of non-combustible matter or ash and low moisture content. So dry fuel increases its calorific value. Fuel should be readily available in bulk and in a ship rate. Fifth, the combustion speed of a good fuel should be moderate. It should not burn spontaneously to avoid fire hazards. The combustion of a good fuel should not be explosive. And last in the list, its handling should be easy and should not give poisonous gases after combustion. So now we know that a good fuel should have a high calorific value. So by definition, calorific value of a fuel is the total quantity of heat liberated when a unit mass or volume of the fuel is completely burned. Heat energy is measured in terms of calorie or kilocalorie, wherein 1 kilocalorie is equal to 1,000 calories. Calorie is the quantity of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. So we have two different expressions for calorific value. The first one is the higher or gross calorific value. It is the total amount of heat produced when unit mass or volume of the fuel has been burned completely and the product of combustion has been cooled for room temperature. To get the higher calorific value or the gross calorific value, it is the sum of heat of reaction and the latent heat of steam produced, and the sensible heat obtained by cooling the combustion products to room temperature. The second expression is the lower or net calorific value. So it is the actual amount of heat available when unit mass of the fuel is completely burned and combustion products are permitted to escape. To get the lower or net calorific value, it is the difference of the higher or gross calorific value and the latent heat of water vapor form. So since 1 gram of hydrogen gives 9 gram of water, then the net calorific value is equal to the difference of the gross calorific value and the mass of hydrogen times 9 times the latent heat of steam. So the unit of calorific value expressed in either calorie per gram or kilocalorie per kilogram, or in British or in English unit system is British thermal unit per pound in case of a solid and a liquid fuel. While for gaseous fuels, the units are kilocalorie per cubic meter or British thermal unit per cubic feet. So we have two ways to determine the calorific value of a fuel. First one is the bomb calorimeter. It is used to determine the calorific value of solid and liquid fuels. The apparatus consists of a cylindrical stainless steel bomb, the lid of which is screwed to the body to make it airtight. Through the lid, there is one oxygen inlet valve and two electrodes. In the bomb, there is nickel crucible attached to a ring. The sample fuel is placed in the crucible. An electrically heated magnesium wire touches the sample. The bomb is placed in a copper calorimeter, which is surrounded by an air jacket and water jacket, which minimizes the heat loss due to radiation. There is a stirrer and a Beckman's thermometer, which can accurately measure temperature up to N/100th of a degree. So a weight mass of a fuel placed in the crucible is allowed to burn in oxygen by electric spark across the electrode, and the heat liberated is measured by the principle of calorimetry. For example, the heat liberated is taken by calorimeter and water. Then the initial and final temperature of the calorimeter can be get by adding the weight of the mass of water in grams and the water equivalent in calorimeter multiplied by the difference in temperature and all divided by the mass of fuel. Another expression to find the gross calorific value is according to Dolong's formula, in which the chemical composition of fuel is represented. So the chemical composition of fuel are usually carbon, hydrogen, and sulfur. So here's the formula. And another expression of this formula is this one, where the carbon, hydrogen, oxygen, and sulfur are the percentage of carbon of these elements in the fuel. And assuming that oxygen to be present in combustion with hydrogen as water. So we're going to have this formula wherein 1 part of hydrogen gives 9 parts of water and the latent heat of steam is 587 kilocalories per kilogram. The next apparatus used to determine calorific value, specifically for gaseous and liquid fuel, is the Boyce calorimeter. So in this apparatus, we know that volume of gas is burned at a uniform rate by a burner. Around the burner, there is a chimney containing coils wherein water at a constant rate is passed. Separate thermometer measures the incoming and outgoing water temperature. So the formula used to get the calorific value, the net calorific value, is this one, where L is the higher or gross calorific value, and M is the mass of steam condensed, and V is the volume of gas burning.